look at finding limits algebraically. And here are a couple steps that we can use to find the limits algebraically now instead of graphically. Because sometimes we're not quite sure what's happening with the graph, but algebra, then people are like, oh, I'm good at algebra. So the first thing that it says is it says plug in A. It's called direct substitution. But what A is it's the limit as x approaches 4. In this case, it's A. 4 is A. Or as x approaches negative 2. Negative 2 is A. It's what we are approaching in our limit. If we can figure out the value with that A plugged in, then we know what our limit is. If we can't figure it out, like for some reason we get undefined, then we're going to have to factor and cancel and try plugging A in again. If we can't, if both of those ways fail, then we don't have an answer. Then our answer is infinity or negative infinity or doesn't exist. But you're going to discuss that more in calculus. So again, I think people do better seeing examples than necessarily seeing the words. But the first one says the limit of, as x approaches 4, of 2 divided by x. Well, we're going to take 4 and we're going to substitute it in for x. Can we simplify that? Yes. We get 1/2. And that's our limit. We can figure it out by direct substitution. The A value in problem number 2, the limit as x approaches negative 2, we're going to substitute in that value of negative 2 in for x. So this time it's 2 divided by negative 2. And it's a legitimate number. 2 divided by negative 2 is negative 1. That's the value of our limit. When we substitute in negative 1 and for x, our A value is negative 1. So this is going to be 2 divided by negative 1, which is negative 2. But over here, the limit as x approaches 0 of 2 over x, this is 2 divided by 0. What does 2 divided by 0 equal? It's undefined. Which means that our limit does not exist. If we look at the next group here, the limit of x. If we put 9 back in for x, we get 9. If we put negative 30 back in there for x, we get negative 30. But over here, on number 7, x approaches 2. We don't have an x to substitute in. So our limit, as x approaches 2 of 5, must simply be 5. We're not going to change anything with the x approaching 2. Same thing here with number 8. The limit of 6, as x approaches 0, again, we're not putting anything into the function, so we're not going to change that value. So hopefully, as we work through those, they seem not too complicated. A little bit more direct substitution. Once again, we're going to take the negative 2 and we're going to put it back into our function. This is going to be negative 2 squared minus 4 times negative 2 plus 1. Negative 2 squared is 4. 4 times negative 2 is 8 plus 1. And you can type this in your calculator, but be really careful if you do type it in your calculator because negative 2 needs parentheses when you square it. So the limit as x approaches negative 2 of this function is 13. Problem number 10, same kind of thing. Direct substitution. We're going to put the negative 2 in for every single x. So it's going to be 2 times negative 2 minus 6 divided by negative 2 minus 2. And 2 times negative 2 is negative 4 minus 6 over negative 4. Well, negative 10 over negative 4. And again, you can type this in your calculator, but when we simplify that, we end up with 5 halves. Negative divided by negative is positive. 2 goes into 10 5 times, and 2 goes into 4 twice. As we flip our paper over, we look at number 11 here. When we do direct substitution on this one, again, the negative 2, our a value, is going to replace every x in this function. Be careful if you're typing it in your calculator, because we need that parentheses. But the thing to notice, without even figuring out the value of the top of the fraction, is what's going to cause us a problem is the value in the bottom. When we have 0 in the denominator, like we saw in example 4, our limit did not exist. Well, negative 2 squared is 4, and 4 minus 4 is 0. We cannot figure this value out with direct substitution. What we need to do, then, our next choice, is to figure out if we simplify, and then use what's left, can we figure out a value? So, the words didn't come out very well, but if we factor the numerator, what we get is we get x and x, the factors of 8, that combine to be 2, are 4 times 2. And let's see, it's going to be negative 4 and positive 2. Can we factor the denominator? Yes. Easiest type of factoring, the most missed. X squared is x times x. 4 is 2 times 2. It's the difference between 2 squares. Do we have anything exactly the same on the top and on the bottom? The x plus 2's. They cancel out. Well, once we get our expression into this format, we're going to try direct substitution again. We're going to put the negative 2 back in for x. So it's going to be negative 2 minus 4 back into the remaining value. And we're going to put negative 2 back in for the other x. Well, negative 2 minus 4 is negative 6. Negative 2 minus 2 is negative 4. We can get a legitimate value now. And once again, negative divided by negative is positive. If we simplify this fraction, 2 goes into 6 3 times, and 2 goes into 4 twice. So our limit, as x approaches negative 2, of that entire function over there, ends up to be 3 halves.